I guess I'll keep going. You know, and if this does not come true, there are some resources about this package online, so I guess I could also redirect to that, but hopefully, so yeah, and it looks like this also gave time to more people to join, so it's pretty cool. Let's get going. So DynaMaps is a project that was born at a Dynamo hackathon. It was in London. And it just has, you know, it actually wasn't the main project of for the hackathon. It was just a side project of something else we were building that necessitated a lot of site information, and we had trouble getting that site information. So, you know, I felt like there was a need for something to get that pretty quickly, and this is how it started. And then after the event, it got developed some more and released as a package on Dynamo, and so I'm going to show it to you today at its current stage. I'll be honest, it has been at this stage of development for, I would say, a year now. It's working, but there are some issues that I really hope we'll stumble upon today. So I get to maybe show you a couple of workarounds on how to solve it. I think that would be very important because I get a lot of questions about that too. So DynaMaps is a package that connects many things inside Dynamo. It connects OpenStreetMap data for the building information and also for road information and planting information. It can also get information about the trees. And the cool thing about OpenStreetMap is that it's free and it's also a very impressively accurate data source, and it's global. It covers the whole surface of the Earth almost. You know, it's very rare to stumble upon a spot that has no information on OpenStreetMap, which is very impressive. It's a community effort, and that's what makes it so great. There's also the SRTM, which is NASA's topography database, and that's the information that's used for terrain elevation information. That's also brought into Dynamo through DynaMaps. There's Bing Maps, which is really just used for the user interface. It's really not a source of data. It's a source of you know, controls for your the window where you can browse a map that I'll show you later. And the outcome is, or at least the idea that brought to the creation of this package was to be able to bring all of that inside Revit. But DynaMaps is actually a package that's free from any other software. It also runs in Dynamo Sandbox. So that means that you can use it in Civil 3D, you can use it in Forminit. I've had some instances of people coming to me regarding those Dynamo integrations, and it all seems to work fine. So I'll be talking about Revit today, but know that that's also something you can use in Forminit and Civil 3D. This is the information we're going to be bringing inside Revit. And by the way, these shots here are generated from geometry that was created with DynaMaps. So buildings, roads, topography, also trees, which we don't get to see in these. Yeah, they're visible here on the right-hand side of the screen. This is Central Park in New York. This is another park in Paris, Jardin du Luxembourg. So yeah, these are just some visuals of what you can achieve using DynaMaps. And the way the package is constituted is, it has actually two parts. The first one is a view extension. So view extensions are, I don't know, it's a specific name for Dynamo plugins. So yeah, it's a Dynamo plugin. It's something that will let you open this little window here where you'll be able to browse the map like you would browse Google Maps or Apple Maps or anything like that, Apple Plans or anything like that. And then you can push that information to Dynamo through this window. Now, when the information is being pushed to Dynamo, the other side of the package is what's going to help you. So that part of the package is constituted by a set of nodes. And those nodes are here to, well, get the information. So this live section here is what's going to exploit the raw data that's provided by all these databases that I've mentioned earlier. So this is where you're going to get the footprints of the buildings and the points for the elevations and the curves for the roads, etc. And then there's a couple of utility nodes, and these are here to help you rebuild a chunk of map in 3 dimensions. So these here are completely free from the databases. They are just here to help you get to, I don't know if you can see this image, but get to these, wait a second. Get to these types of geometries faster. But what they are is really just some design script inside nodes, inside zero-touch nodes. All right, so I think that's everything that you need to know about DynaMaps before we can get started. And I will be today in Revit 2021.1.2 with Dynamo 2.6.1.8850. So these are the versions we're going to be working in. And just so I can give you the full experience of someone who's never used DynaMaps and who wants to get it, here's how you can do that. You go to the package manager, just like as if you were looking for Rhythm or Archilab or any other great package that's out there. Type in DynaMaps and you'll find it right here. You can download it.
Data-Shape.
Oh yeah, or Data-Shapes, yep. Same process. If you like it, you can upload it and you can download it. So it says that it contains some scripts, and it actually contains more than just Python scripts. It contains some binaries. And when it's installed, you'll get the nodes here. So those are the set of nodes I was talking about in the 3 sections, the live nodes, the Revit nodes and the utils, and the view extension is going to be right here in the view tab. So it's very straightforward. You just go to the package manager, you download it, and all of this is going to appear. You don't even have to restart Dynamo or Revit or anything. Now that we have it installed, I'm going to launch DynaMaps. So this is the view extension. This is the plugin that lets you browse maps. You can zoom in, zoom out, pan on this map. It's this type of interface is something people really got used to over the past, let's say, decade. So you should feel at home in here. Now let's look at some New Zealand spots. What I like to do is always, find a location that makes sense to the audience. So I was thinking maybe the office that you are in, Monica, if you don't mind giving me the address.
Yes. Pakenham Street.
How do you spell that?
How do you spell that? P-A-K.
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 P-A-K. E-M.
E-N. A-M.
H-A-M.
Or otherwise we just do Windows Auto Finder.
Yeah, I mean, or what's the name of the company, the building that?
Warren and Nunn.
Okay, I don't know. Actually,
Jazz makes this easier. It's not his office.
all right, excellent. Someone very helpful has just written it in the chat. So that's perfect. Thank you so much. Thank you for the help. All right, so I've just entered this address. Hopefully, it's going to recognize it. Is that it?
Yeah.
Cool. So yeah, I didn't mention this, but this is also using another service that's called Geolocate, and it's not the Google API. It's not the Google Maps API that it's using. This one is completely free, and it's able to convert an address into coordinates, and this is what's used in here. And yeah, as you can see, the map can be switched from satellite to just plan. And yeah, here's our site. This is what we're going to be dealing with. Now, just a couple of information about how to proceed in order to not get everything to crash. Because the thing is, we're dealing with very large amounts of data here, potentially. So sometimes people get a little overexcited with this and they zoom out a lot and they just try and bring a whole chunk of city into Dynamo. This, it might work. I'm not saying that it's never going to work, but the more you zoom out, the more information, like in here, there's probably maybe 10,000 buildings, and it's just going to be too much for Dynamo to handle. Even though with the latest versions and with the great work that your people at Solamour at Dynamo is performing, the performance is increasing in a very rapid way. But I feel like today you should still maybe restrain yourself to not zoom in out more than this.
Is there a way to change the increment when you zoom in and out? Because when I was trying Sorry, go ahead. Because when I was trying it, like right now, when you zoom in and out, it goes from 500, I think, to 1,000 feet. Or if you want something in the middle, is it possible to have a specific area?
That's really, really a great question, and it's actually not the first time it's come out. And I'm writing it down again. It's just part of the list of things that needs to be implemented in the plugin. That is not there yet. But yeah, I should take some time and do that. You're right. Today, if you use the mouse wheel to zoom in and out, it's like the gap is way too large between two positions, and there should be a way to just like have a plus or minus button here that lets you zoom out in a more sensible way. But yeah, for now, this is what it's like, and this is how this whole part here works. It's rather straightforward, and the next step is to exploit this information right inside Dynamo. The way you can do that is through the live nodes here, the live section of DynaMaps. And okay, I'm just going to switch to manual in order to keep things working. It's way too much here for the automatic mode. And I'm going to pop out the nodes here so we can take a look at them. Topography. Oh, there's two. And the trees, which is always nice, I guess. Not the most useful, but still. All right, so these are the live nodes. The first two here are going to be outputting building contours as polygons or as surfaces and elevations. This one here is going to be exporting or outputting the roads as polycurves. And this one has a UI that lets you actually pick the type of road that you would like to take into account. This naming here is not something that I've invented. This is completely coming from the OpenStreetMaps terminology. So if you ever wonder about what any of these categories here is representing, let me show you. OpenStreetMaps roads wiki. Hopefully, yeah, okay. So yeah, it's the keys. And here it tells you what highways are in OpenStreetMaps. Right, okay, there you go. Motorway, trunk, primary, secondary, all of them are, they're all here. And this list of road types is what you can, is what you can find here in this list that you can then check and uncheck in order to get the information. And then there's the topography as points or as polysurface. And you'll see that we are going to need one or the other for different purposes. Now let's delete these. The reason I'm doing this is, again, something you should keep in mind if you're using DynaMaps. I'm not going to hit push to Dynamo while all of these nodes are out there, because if I do so, it's going to try and output all of these at once, which again might be a little too much to handle for Dynamo. So the best way to go with this is to, just like keep one of them. Actually, let me keep these two, one or two of them. And now let's do this gradually. So just this one, and then I'm going to hit push to Dynamo. And just one last thing is this slider here, which is the topography density. This is what lets you set the amount of points that you're going to be importing. The more points, the more accuracy, of course. But just know that the SRTM database that it's using has I think a density of like 2 or 3 meters. So it's not always very useful to go all the way up to a 40 by 40. Sorry about that. Just mistakenly opened another sentence version of Revit. Let me close that. Okay, so yeah, this here, right. Excellent. Cool. So yeah, this here means that you will have a grid of 40 by 40 points. Again, the more points, the more information, the more the web request is going to be lengthy, and the more it's going to be, the tougher it's going to get to handle for Dynamo. So try and keep this to reasonable numbers. But yeah, this should work. It's just going to be much longer. Let's stay with a 10 by 10 grid for now. All right. Now, when I push to Dynamo, you are going to see some stuff coming out of there, because this button here also triggers a run. And there we go. That was rather fast. Okay. This is a good one. This is among the things that are going to happen often and might get you worried. Here it's saying that the geometry range that we're dealing with is larger than the one where we've set Dynamo at. So the only thing you have to do here is go to settings, geometry scaling, and go for large or extra large, because we're dealing with map data, so these are very large distances. If I apply the changes here and hit this button again, yeah, maybe I need to delete this node and create another one.
Restart it, yep.
Another thing that might not be helping is the units. If I'm in millimeters, all right, yeah. So, how Dynamo inherits the units from Revit, from the host Revit session. And these distances in millimeters are very, very large numbers. So that's also why we were getting that warning. All right, much better. So that seems more reasonable. There's actually not a lot of buildings in here. If I zoom out, just for fun, and run it again.
You also chose a flat site. We should have chosen something a bit more difficult.
Oh yeah, the site is flat. Well, as you can see, this is already, giving it some trouble. Okay. I was just showing that, okay, I think it's this part here. There's maybe like a residential lot or something with a lot of small partials. And that's why it took so long the second time. But yeah, theoretically, you should be able to export large sites. It's just a matter of patience after that, because, a patience and also taking a little risk, because with very, very large amounts of data, you might get some crashes. And nobody wants that. Okay, so let's zoom back in and run it one more time. And we'll stick to this just for this demo, so we don't wait a lot between every step. Okay. Now what I have here is just...
What is that blue patch there?
And here, this is just, Dynamo's plan. There's a little it's the origin of the Dynamo workspace in here. With
Yeah,
the
yeah,
X
I
and
got
Y
it, I
axis
got it.
and Z. Yeah. So it's just that. And you know what? Let's maybe hide it. I think we can turn it off. Show view, show console, background. Yeah, show grid. There we go. Okay. Now what we have is polygons. So this might be useful. In some cases, this is all I needed. So it was great to be able to get it fast. Most times what you're going to need is the actual, the footprint of the building as a surface, because that's what you're going to be able to extrude, especially if there's a relationship. For example, in here, there's a building with a courtyard or something like that in its middle. And when you're just getting the polygons, these two here are not attached or linked in any way. So if you try and get an extrusion of this building starting from these poly curves, it's going to just have one big extrusion and a smaller one inside of it. Not exactly what you want. Whereas this node here, what's going on? Okay. Yeah, this node, it already has this type of Boolean operation dealt with for you. Another very important information that you'll get out of this one is the elevation. Now, the elevation is an information that comes out of OpenStreetMaps when it's available. So it tries three things. The first thing it tries to do is get the actual elevation information of the building. If that's available, it's going to use it. If it's not available, it's going to look for another information, which is the number of levels of that building, and it's going to multiply that by 3 meters, assuming that the height of one level is 3 meters, and you will get that value, which is a rather good approximation of it. If none of that is available, what it's going to do is find the smallest height and then the biggest height inside this area here that you're working with, and it's going to generate a random number in between those values, just so you don't get things that are completely flat. There is a way, though, to identify those in case you don't want that type of randomization and you want to handle that manually. And I'll show you how those can be identified. So, by the way, the first time you hit the Push to Dynamo button, it's actually written somewhere in your temporary files on your computer, so you don't need to keep this open. This is nice to have at the beginning because it's a great way to see what you're dealing with and export the information. But once that is done, you can just close this and get to work in the Dynamo canvas. Just hit and run is going to get these nodes to fetch that information and output the geometry. Okay, here we go. So we have the surfaces now. And as mentioned earlier, we do have the surface with the opening and not just two surfaces on top of each other. I'm going to keep this one here for just because it looks better when it has the contours. Okay, let's get the roads. And I'm not going to get too crazy with roads. I'm going to get primary, secondary, residential also. Tertiary, no track, trunk, okay. Yeah, these are what I usually use. And they are usually enough. Okay. Does this look right to you? It looks like it's not much. Let's see how much we can get. All right, yeah.
There's a motorway the other way. That's the motorway as well. It's kind of at the end of the motorway. It's a cyclist motorway.
Oh, the motorway, okay.
Yeah, it's the motorway.
All right. Okay. Yeah, I'm afraid this might be a little too much, so I'm going to try and filter it as much as possible. This is part of what you're going to be doing in DynaMaps, so It's good to see it together. Motorway, path, pedestrian is not relevant here. Okay, residential, secondary. Tertiary, okay. How about now?
That's about right. I think there's also a couple of pedestrians.
Yeah, okay.
So
let's try. The thing with pedestrian is sometimes, it's just like a pedestrian path on top of another road that's existing. So that's why. Okay, yeah, no, it's actually, I don't know.
It's along the water.
Let's see, this.
This does not work very well,
Okay. All right, yeah, let's keep pedestrian. As you were right, it doesn't look too bad. I mean, it actually looks interesting. I mean, it looks like interesting data. Okay, I guess we can stop there. You'll see, like this. Actually, this is what I'm worried about. When you have several paths right next to each other, this is the type of data that, from experience, I know is going to give us a hard time when we try and generate the surfaces of these roads. So, I guess it's good that we can take a look at it together, and I can share some of the workarounds that I've been using. Okay. Now for the topography, let's get the poly surface and run. This one is a little slower to perform because, the first push was getting the OpenStreetMaps data. This one here is performing some other web requests to SRTM. This is why it takes a little longer, but actually it went pretty fast here. And here's our topography. As you were saying earlier, it's rather flat, so there's nothing crazy going on. It looks good. This really is fun to try against, regions such as like the Grand Canyon or things like that. It actually works. And this is what I was testing it with when I was developing it. I was trying to make sure that I was looking at the right spot and that the information was correct. And the Grand Canyon is a great way to test that type of tool. So here,
we have contours from the council maps as well, from the council geo maps. Can we link that to this data maps? Is it possible or not really?
So contour, you have contour curves and you would like to build a surface from them, right?
Yep.
Okay. Well, DynaMaps does not have anything of that sort for now. It's really limited to what I'm showing here. So fetching data from those data sources that I've indicated. There are no utility nodes for building surfaces from contours, but
there is. What we're currently using is just to create the topography in Revit, and then I just get the topo surface from the topography, and then I use that to link to the other nodes that you showed us on.
Yeah, definitely. That is something that's going to work.
That is how I've done it as well in the past. Thank you.
Yeah. No problem. Yeah, the topography in Revit is going to help. I was actually tempted to show a quick little example where, when you get curves, you can place points on those curves, with points at parameter. You can place as many, and just so as you reach the level of accuracy that you're interested in. And once you have those points, you can add them to a slab or a topography. So I think that's what you were pointing at. But yeah, if we have time at the end and you're interested in that process, I guess I could go through it. So yeah, now back to the utilities, because this is what we're going to need for the next steps. We are going to use this little utility node that projects these building surfaces, the building footprint surfaces onto this topography, and also extrudes them in order to get buildings that look like what we have in this little image here. So this one shows the roads, etc., but it's really the buildings it's going to output. Now, it's asking for a couple of inputs, which are, I think, rather easy to understand. So the first one is the footprint surfaces. This is this output. It's asking for the building elevation, and yeah, this is the opportunity to talk about what I was saying earlier in those randomly generated values. So in here, you'll see that it's very easy to distinguish between values that are actually coming out of the database and values that are automatically generated between the minimum and maximum of the region, because those random values are going to look something like this. So you can convert them as string and count the number of characters and know just use that as a filter to know which one is real and which one is randomly generated. As you can see, there's quite a lot here. So not all the buildings have data in this region. And in those cases, what you can do, and that's what I try and encourage people to do that as often as possible. I do that myself, and DynaMaps has brought me to do that myself a lot. It's actually go to OpenStreetMaps. They have a great website and a great user interface online, and find that building and enter the information if you have it. And for the elevation, it's sometimes as easy as looking at it through a Google Maps satellite view, counting the number of levels and doing that multiplication, or actually just entering the number of levels is going to be useful for DynaMaps. So this is something that could be great to do, because the moment you do that, it becomes available to everyone, and it's going to enrich that database that we're using here, and that is also being used for tons of other applications. All right. Now that we've done that, now that we've talked about that, we can connect this. There's the topography polysurface that it's also asking for. We'll get that from this node. And then it's asking us if we want to crop to topography. Basically what this means is, since some of the buildings here are outside of the zone, if we've been selecting square zones of geography, and the buildings that have even small parts in that zone, they're going to be brought completely. They're not going to be truncated at the import. So this is why this exists. It's actually a suggestion to perform that crop for you and to get something that looks a little cleaner, like this. So it's really not you're not obligated to do so, but I'm going to do it because why not? Okay. All right. So yeah, taking a couple of seconds here.
While it's loading, quick question, Mr. Bob.
Yeah.
You understand is that is regarding the coordinates, it's going to be a world coordinate system. Is there any chance that we can change the coordinate system if we want to show the information through?
Okay. So that's if you want to get this information outside. You want to push it to Revit at some specific coordinates. Is that right?
Yeah, exactly.
Okay. There's an issue with that, and that is that Revit has this limitation in terms of how spread your geometry can be. It's like something like 21 or 22 miles or something like that. The problem if you're trying to output geometry to Revit that is at its world coordinates, it might actually be very, very far from the origin of the project, and that might be a problem. So this is why this here is really talking to the project origin, the project base point in Revit, and there's actually something that can help with what you're talking about. It's this thing here. If you have your project coordinates properly set up in Revit in the project base point, you can ask DynaMaps to take you there. It's going to use that information, the longitude and latitude. And once it gets there, you can push to Dynamo. So the information is going to be centered in the Dynamo workspace, just like it is, around that, around those coordinates in Revit. Does that make sense?
Yeah,
the only problem with this, though, is that if this is going to take you to your project coordinates with a certain zoom level, if you zoom out, it might get a little, dragged on the side. So that's a problem, and this is another thing that a plus and minus zoom button might help with, because it would allow you to zoom in and out while staying completely perfectly centered on the origin. So yeah, another point for the implementation for that. I hope that answers the question.
Yeah, thank you.
No problem. Okay, so it did run, it did build, get us the buildings. It does not look wrong, because lots of heights were generated automatically, and I was a little curious on how it was going to come out, but it actually looks good. Another thing that I do a lot when working with DynaMaps is use this node from Revit. I think it's in the utility from Revit, from Data-Shapes this time. Okay, I'm just going to look for it. It's called Geon Preview. And this one here lets you give it any geometry, and then you can expand it and pick a color. There are other nodes to do so in Dynamo. There's like the color palette, and there's a geometry color by geometry color, which are going to do the exact same thing. The only cool thing about this is the user interface, where you can deal with the transparency as well as the color in one node. So just give it the geometry and pick the color. I'm going to hide the preview for this one, otherwise they're going to be on top of each other. And there we go. So we have our buildings. You can see there's a little transparency. Okay, that's not too bad. That way we better visualize what we're dealing with. Okay, so these are our 3D buildings. Now for the roads. Roads have another set of utility nodes. Some DynaMaps. Roads, okay. We can get roads as surfaces from these polycurves, or actually as a polysurface. And the information about the width, well, that's also something I get asked about quite often, but the problem here is that the width of a road is not necessarily, it's not consistently available in OpenStreetMaps. So maybe I'll need to find another database that provides that information, but the solution for now is to enter a value yourself. So here I'm going to say that it's 6 meters. And yeah, this is not the most accurate thing in the world. But again, this is for early stage feasibility studies where you get some site geometry that's going to help you whether run some solar studies, see the shadows you're projecting on other buildings or that other buildings are projecting on your building. Also, I don't know, generate some context for your visual reality experiences, etc. This is not really something that's going to be used for official documentation or things like that. All right, so it did work. Surprisingly, I'll be honest. I think it's rather surprising that it worked so well because it's
because there's not much of roads there actually.
Yeah, there are not much, but the thing, what surprises me is that there's a lot of them that are very intricate, and I was expecting that to generate some errors. For example, this here. Yeah, these guys here worked surprisingly well. But hey, I'll take it. Now, okay, let's see what happens when we ask for everything. I believe this is going to give us some trouble. And what I'm going to do here, I think that could be useful to everyone who's trying to use DynaMaps, because this is probably the question I get most, maybe once or twice a week, ever since the package came out. I get an email saying that this node here is returning an error. And people don't exactly know how to deal with it, which is understandable because, you know, it's just, I mean, you don't know what's happening inside. So what I'm suggesting here is to take you through exactly the steps that are performed inside this node. It just felt like a good idea to build a node, a utility node that does just that, and that is, you know, available for you to throw on your canvas rather than having to rebuild that logic every time. Okay, this was a bad idea, I think. Way too much stuff. Let's give it another minute. Okay, all right. Yeah, it really does not want to crash today. It's been very cooperative. So I don't get to show you the problems. All right. I don't know. Okay, I'm just going to keep them here. But still, I would like to cast some light on whatever is happening inside this node. So what I'm going to do for that is, okay, take another one of these with less information. Okay, so I don't know, primary, let's say primary and secondary. All right. Okay, cool. So we have some polycurves. This is what this node does. It extrudes the polycurves. So let's go with direction and distance. And you know what? While we're doing this, I'm just going to hide everything. Oh yeah, and use another feature from Data-Shapes, which is, oh no. Primary and secondary. Yeah, in Data-Shapes, you have a view extension that lets you do this. Hide all unselected. So if something is not, if a node is not selected, its geometry is going to be hidden. And now we're left with just these two. Okay, so we want to extrude it, yeah, by, I don't know, 10. Okay, I was expecting this. It's not always good at understanding the direction we want. So I'm telling it this time to go following the z-axis. Still not happen, still not happy. Okay, interesting with stuff. Right, so you know, it's funny enough, this is the type of issue that you're going to be getting. Here it looks like some curve is self-intersecting and it just does not want to extrude it. Oh, extrude a solid, no. Extrude a surface.
Is there any way to differentiate between different types of roads, or as you plug them in, they're all pretty numbers? Like, can you upload different ways to the roads depending on what type of roads they are?
Definitely, that's something you can do, and the way you'd go about doing that is, you know, by having a couple of these nodes out there, and have, you know, one for just the primary, another one for residential, and then you'd be able to apply different widths. So yeah, there is no way here to distinguish between them. Maybe I could have had like one output per type, but it would have been way too many outputs. The node would have looked awful. But yeah, for now you can have a couple of these and separate roads as surfaces nodes. Okay, so back to this one. Now that we've extruded these curves, I'm going to thicken them, both sides. Give it a width, give it a true So now we have this, okay? So that's a couple of solids. Now what we can do is run a union of all these solids. So it's this node. And really, these are the exact methods, the design script method that I'm using inside the other nodes. So if this node is giving you trouble, this one here, try and rebuild this, and it will show you where trouble is happening and hopefully give you hints about how to solve it. So here I have a unique solid, and if I run an intersection with that plane, geometry other. So all of this comes at 0. So I'm just going to give it the XY plane. All right. I'm hiding all of this, keeping just that. And there we go. So this is exactly how it gets built. Now, no more secrets. And this is what fails sometimes. And it's also much faster when it's run inside a zero-touch node. I haven't actually performed a benchmark on this against that, but yeah, just the fact that it's not having to render visually each one of these steps, I think is a great performance gain. So that's why this node is still interesting. And I think like it works maybe 8 out of 10 times. But those 2 times it doesn't work and it's on the stuff you actually need, it can get pretty frustrating. So this is why I'm sharing this little workflow here. Hopefully that will be useful. Okay, but we don't need this here because everything works great in Alkaline. So let's show this again. This one until we perform some Boolean operation on it. All right, next step. So we were talking about roads. The next step is to project the roads onto the poly surface of the topography. So it wants the...
Hey guys, just a reminder, can you please mute yourself? I don't know how to mute other people. I can't mute other people. So if you can mute yourself unless you're talking.
So someone is speaking French. Okay, so this one wants the road surfaces and the topography poly surface. Okay, we do have a lot of things going on here. So again, it might take some time.
While that is running, there's just a question from before about what is the lowest scale that you can zoom in. That's when you import the data.
Okay, yeah, that's a good one. I don't have the figure, but I can tell you that whenever you reach that limit and try to push to Orkestra, you're going to get an error message that says that it's a bad request. That means that you went too far. Mm-hmm. So yeah, that's, I guess we could test it out when we write this down. At the end, when we're done with this, I will pop out that view extension, the DynaMaps view extension, and zoom out until it tells me that the request is bad. And the limitation there comes from OpenStreetMaps actually, because what DynaMaps does is it sends web requests to OpenStreetMaps using coordinates, and the error message comes from OpenStreetMaps when the request is too large. Yeah, I shouldn't have gone with that many roads. I always get a little too ambitious with those. It's like last time I gave this presentation, I made a mistake that I won't make this time. It's during the process of bringing all this geometry inside Revit, I was trying to build the building paths at the same time, and that is another very, very lengthy and expensive operation. So yeah, it was spinning for a couple of minutes. All right. Now, hopefully when this one is ready, we don't have to touch it anymore, so it'll be fine. By the way, you know, this I see that we're getting close to an hour. I was just wondering what the limit was.
Question. I think besides 7.
I'm enjoying it. I don't mind if you continue longer.
Yeah, I think we're all happy for you to keep going.
All right, great. Yeah, this was really too ambitious. I sort of want to, you know, bring another instance of Revit and maybe rebuild this. This part is going to go pretty fast. Sorry about that.
I think we're used to this.
Yeah, well, definitely. It's just when you're alone, you go make yourself a cup of coffee, but here, we're all just looking at it. You know, surprisingly enough, I mean, I'm not sure why it's taking so long because, again, if I break down the steps that are going on inside this node here, it's not so much. It's actually just, you know, once we get this surface here, the same way I got it earlier, so we get a flat surface that is the union of all the roads, it gets extruded upwards, and then it performs a Boolean operation with this polysurface here. I think what's making it take a long time is how Dynamo, I mean, when you perform a difference or, I mean, yeah, a Boolean operation with the polysurface, it sorts of does it with every, oh, excellent. I'm so happy. This is great. Okay, it worked. So let's go ahead and visualize this. So these are the projected roads. Let's give it something very dark. No, it's the opposite of what I want. Yeah, you can also enter RGB values here. Okay. And the trim topography, thing like this. Okay, that should not look too bad. Going to hide this. And this as well. All right. So that's not too bad. There we go. We have our roads and our buildings and our topography. And yeah, it took us, well, I was talking a lot during the process, but yeah, this is something that, you know, if you just, you know, from start to finish, it's actually something that I have stopwatched myself on because I really was curious. And I did it on something that I actually needed. So it was not just messing around with some testing. It was on a real project for real needs. It took me 10 minutes, which is not too bad. Especially since, you know, once you get all of this going, you actually can get it inside Revit where you can really use it for all the use cases that I've mentioned earlier. So that's pretty cool. Okay. Last thing, maybe trees, because the information is there, so why not? 3 points. Okay, there are some, as you can see. We need to project them. Huh. Okay, this is interesting because, yeah, you guys are not very far above the sea level.
I was gonna say you need a note for the water as well. Distinguish the ground from the water.
Oh yeah, that's right. You're right. Yeah, there is some water in here. This here is it's true. And that information is available on OpenStreetMaps for rivers and ponds and things like that. So this is something that could maybe be implemented. That's true. Okay, so this here, very straightforward point projection. And we're going to project these points onto the initial polysurface. That way we get the full geometry. The direction is this, oh yeah, no, I moved it. So it's the z-axis. And then there's a little utility for trees, which is going to place this type of geometry for each point. Again, not the most useful thing ever, but still, I think it gives you an appreciation of how a site is completely tree-free or if there's some green going on. Okay.
Well, let's go in. So there's a question in French. Now, my French is not very good. Can you see the question?
I know you understand French. I prefer ask you my question in French. You can answer in English. Okay. Okay. I can try and translate the question. So it says that that person knows InfraWorks, and they note that InfraWorks also uses some of the OpenStreetMap data, and they're asking about the difference between InfraWorks and DynaMaps. Okay, so first difference, I guess. Okay, so actually InfraWorks, it's a large software, it has a large team behind it, and the thing is they support much more data sources than just OpenStreetMaps. I don't know if what I'm saying here is true, but I would not be surprised at all if they had connections with the Esri database, because I think Esri has a strong partnership with Autodesk. So there's plenty of data sources being used in InfraWorks. It also has its own rendering engine. So yeah, the difference, I think it's for very, very different use cases. What DynaMaps is good at is building focused sets of geometry that you can exploit inside Dynamo for studies, solar studies. I don't know, with the generative design, you can perform all types of studies. It gets interesting. And you can also get that geometry inside Revit. That's the strong point of DynaMaps. InfraWorks allows you to bring, earlier I was talking about bringing CDs which was not possible in DynaMaps. I think InfraWorks can do that. So it's for larger scale. It's also for more data, more comprehensive data. But I would say it doesn't have a connection with Dynamo and Revit that is as direct, even though I'm pretty sure there are some people out there building workarounds and workflows, interesting workflows. Okay, so yeah, that's what I would say. It's for different use cases. But InfraWorks definitely uses OpenStreetMaps and more. There was a second question. Okay, they said that they've used DynaMaps on a small lot with buildings that were 6 levels height. Okay, yeah, and most of them didn't have the elevation information in OpenStreetMaps. And the random elevations in DynaMaps, yeah, was giving out some odd results because it was giving heights that were too important for things that were maybe not as important. So yeah, the answer for that is actually something that I was addressing while I was talking about the elevations. You can identify those random values because they look different than the rest. If you see a value that has like 10 digits after the point, I mean 10 digital value, 10 decimal values, you know that it's randomized. So you can filter them out and you can enter values yourself if you wish. So yeah, that's it. And again, and yet a better option is to go to OpenStreetMaps. It's free. It's open for everyone to create an account. It's actually very fast. You know, if you make a modification in OpenStreetMap and you commit it, you push it, 15 seconds later, it's available in DynaMaps. So yeah, please go to OpenStreetMaps and enter the data that you wish was there in order to make it available for yourselves and for other people. Okay, so now we have the trees, we have the geometry, we have all of it, and this is what it looks like. Okay, I don't know if you want to just stop it here. I guess I could show how to get the geometry inside Revit. Hopefully it won't take too long, maybe 10 more minutes. And for the orchestra part, I guess we'll have to schedule another event or something like that. But it's, I mean, I don't mind at all. I'm always happy to talk about DynaMaps. So should I do the Revit geometry part?
Yeah, I think so. I don't think it will take too long.
Yeah.
Yeah.
All right, let's go. So there's a couple of utility nodes in here, again, to help you with that task. You can get the building geometry like this. So it's requesting quite some inputs, but let's do it. The footprint surface of the buildings, the building elevation. These didn't come out too bad, so I'm just going to use the randomized values, even though there's a lot of them. You can give it a category. So you can, what I usually do is assign it to the site category. That way I can filter it out and replace its graphics in a rather focused way, because there isn't much more stuff in the site category. The topography surface, so here it is. We already have everything. It's asking us whether we want to adjust it to the topography. This is, it's not phrased the same, but it's exactly the same. So do we want to crop it the same way we crop the buildings here? I always say yes, because it looks cleaner. Do you want to generate the building path? No. I mean, sure, do it on your projects. I think it's good because, when you run sections through the site and the building paths are there, it looks super clean. The buildings are well integrated inside the site. It's really great. It's just going to take way too much time. So I'm not going to do it here. All right. That's it for the buildings. Let's go into 3D view and hit run.
Maybe while that's working in the background, do you want to just tell everybody what Orkestra is about, and then maybe people can just book a session on that you're available to give like 30 minutes presentation?
Sure, yeah. Definitely. That's a good idea. Thanks for suggesting. All right, so Orkestra, it's another project that I've been working on for time passes really quick. It's been more than 2 years. The first year was it's almost been 3 years. First year was development. Second year was beta testing phase with many users from all across the globe, which was amazing. And it's been out commercially and available for purchase ever since November 2020. And what it is a platform for deploying Dynamo content. I think everyone here knows the trouble of building a definition and trying to send it out to other people. And it gets even more complicated when it's for a large group of people. Well, Orkestra is here just for that. It helps you basically centralize the storage of that content on the cloud-based platform. But it also lets you actually access that content in a very, very easy fashion right inside your design tools. For example, here I have Orkestra in Revit, so this is what it looks like. This is a local part which is free. This is where you can point at anything that's on your computer or any mapped drive on your computer, really. So that could be a local server or things like that. And it's a player. It pretty much, for this part here, looks like the Dino browser. And double-clicking something is going to play. Now, it gets very powerful when you log in and get into the online parts. And the online part is where you can deploy stuff, version control your content, deploy the packages as well. So, you make sure that everyone has the right packages whenever they hit and they run a definition. You can associate all types of documentation. So it's really, the platform for pushing your content to a large user base. That's all I'd say about it for now. But feel free to please do go to Orkestra online and request a demo. We'll get in touch with you pretty quickly and arrange a talk. Thanks, Monica.
Thank you, Luxosin.
Thanks. All right, and in the meantime, we got our building. So that was a great use of that time. Here are the Revit buildings. As you can see, they are generated separately, which is really good, I think, because you can then, delete, for example, the building that's currently on the parcel you're studying. You don't have, that's why it's like this. Another thing you can do, and Paul Oben from Chicago, we've had a presentation of DynaMaps with the Chicago user group, and Paul has pushed this to the extreme limit. Honestly, I've never seen someone do such interesting stuff with DynaMaps. He had created parameters and filled the information onto those parameters, and he was able to create some view filters, and he had something amazing going on. He did make also a very, very interesting request, which I still have not implemented yet, but it was to, how those buildings have an ID, an identifier on OpenStreetMaps. Well, the idea was to get that information through DynaMaps in order to keep the link between whatever you have here and the OpenStreetMap database, in case you want to fetch more information through other packages like ELK or things like that. And that was an excellent idea, which is just waiting for implementation. All right, we have the buildings. We don't have the topography yet, but this one is going to be pretty fast. So the only thing we need here is to go back to the live nodes and get our topography points. And then there's a topography by points node. This one is out of the box. No, not this one. This one. So let's run this one first. And we have the points. We feed that to topography by points. And we will get the Revit topography. We can also get the roads. And I guess that will be probably the last thing, but I'm not going to make the same mistake and try and push all the roads. It's going to be way too much. So I'm just going to pick a couple and show you how it works. The primary, the secondary, okay, residential also. Okay, tertiary. That should do it. And then in the Revit section, we have roads as subregions. So it's actually going to build them as subregions of your topography. That way you can assign different materials. Another thing here that is, I think, important to say is it says road polycurves, but actually it wants the surfaces. So I'm sorry about that. This needs to be renamed and republished. Okay. Hopefully this won't give us trouble. Yeah, this one is also some, okay, the input curve not proposed valid boundary. Yeah, this is typically the type of errors you will get. Let's try, yeah, no, definitely not. Okay, thought so. A workaround here is to output these perimeter curves for these surfaces as model curves and then use them to recreate the subregions or something like that. I know it's not the best, but subregions, they want closed loops, etc., and that is not always very clean or coming out like straight from OpenStreetMaps.
I mean, another thing what I have noticed is the subregion, unless it correctly cuts the curve, you are not able to get those subregions as well.
Right. Okay. That's a good information too. Thanks for sharing. Yeah, this one I know it's given me some success. Maybe one thing you can try and do is generate them separately. Again, not all the roads at once, but maybe road type by road type. That might bring you more success. Okay, just, I don't know if there's something black here in English. Oh, asphalt, great. It's exactly what it is. Or I suppose it is. Okay, so here, yeah, I've really not imported all of it, but some of it's here. And this is what it looks like. So you have the subregions on the same topography. And yeah, that's it. So yeah, thank you very much for the questions and the exchange. I really always enjoy that. And also thanks for staying longer than it was initially supposed to last.
Thank you for your time. It was really, really interesting.
My pleasure. And thanks for inviting me.
Yeah, so unless anybody's got any other questions.
Mm-hmm.
Yeah.
I had looked at a lot of your videos on LinkedIn and from the Linda Learn, and I was like, oh, good, you're presenting. I have to be there. Thank you.
Yeah, and I must say, like, I use also the Data-Shapes packages, and yeah, like, thank you. they're amazing, and just putting a good word out there, but you're also really good at replying on your website, on your blog, because I've asked questions in there and I've asked you to change some things and you come back to me in a couple of days. So thanks for that.
All right. Yeah, sure thing. And well, thank you also for reaching out. That's how the stuff gets improved. It's when you hear back from people trying to use it, and it's really, really awesome. Thanks.